Alright, so today we'll be talking about circles. Okay, we'll be talking about the center, the circle itself, the radius, and the standard form of the equation of the circle. Okay, so the standard form is x minus h squared plus y minus k squared equals r squared, where the center is hk and the radius, well, and let me emphasize that h and k, they're going to be opposites, and that's going to be a common recurring theme for conics. Okay, so please understand that. Alright, and radius is going to be the square root of r squared, which is r. Okay, now the general form is going to be x squared plus y squared. Let me put in that squared part. I think I forgot to put it in when I was typing. Plus dx plus ey plus f equals 0. And d, e, and f are all constants. Okay, so that one's pretty simple. Now if you notice, I'm missing an a, b, and c, and we'll talk about that a little bit later on as to why I'm missing those, but you'll understand in a sec, okay? Alright. So, some really quick things to talk about. We explained in the analytical geometry part that a circle is it's a figure where all the points are equidistant from the center point. So we would call this radius r, okay? And we would call this radius r as well. Okay. So no matter where I drew the radius, the actual measurement is going to be the same as any other radius I draw. So these are going to be congruent. So that's pretty simple. Alright, so enough talk. Let's start practicing some of the work. Okay, so here's some example problems. And let me move this a little bit. There we go. Okay, what is the center and circle of what is the center of the circle and its radius? Blah. I almost screwed that up. So the center is going to be pretty easy. The center is going to be the opposite. So it's going to be 16 comma negative 6. So that one's pretty simple. Now the radius is going to be the square root of 121, which is, I know some of you guys are going to say, oh, it's plus or minus 11. And some of you guys might have totally forgot that whenever you're doing a square root, you need to have a positive or negative version. But since we're dealing with the geometry side of it, we're just going to use 11. Okay. All right. Now this one's a little bit more complex, and you're actually going to have to use completing the square to actually find this. Okay. So what we're going to do is we're going to rewrite it first as x squared plus 8x plus y squared minus 10y, and I'm going to bring the 8 over, minus 8 equals 0. So that's in standard form, because this is usually the typical way it brings it up. Okay, so what I'm going to do is complete the square with the first two. So I'm going to do half of 8, which is 4, and then add that, and square it. I'm going to get 16. Then the next one's going to be y squared minus 10y. Okay, half of negative 10 is negative 5. Square that. That is positive 25. Okay. Now if you notice, I'm leaving the 8 alone. On the other side of the equation, since I'm such a gentleman, okay, I'm going to write the other parts, because if you remember, if we add these two random numbers of 16 and 25 to one side, we must add it to the other side. So this is going to be 16 plus 25 over here. Okay, now what I'm going to do is factor these first two down. So that's going to be x minus 4 squared. No, not x minus 4, x plus 4. And then this one's going to be y minus 5 squared. Okay, and this is going to be equal to, I believe 16 plus 25 is 41. And then I'm going to add 8, and that's going to become 49. Okay, all right. And the center is going to be negative 4 comma 5. And yes, the h always goes with the x, and the k always goes with the 5. And the radius is going to be 7, because it's the square root of 49. Alright, so now what we're going to do first is we're going to actually go through a problem where you're given 3 points on the circle and you have to find the equation. So if you remember from before, you use the standard form and you actually start to solve this. So what we're going to do is we're going to write out the equation 3 times. And we're going to put the numbers in place of x and y in each. Okay, so if you notice, I have 3 points, so that means I'm going to be using 3 standard equations of the x squared and the y squared. And the standard form is this one right here. Or I'm sorry, not the standard form, the general form. Okay, so I'm going to write it out first. Let me see, what was it, x squared? So the first one's going to be 5 squared plus 3 squared plus d times 3, or no, d times 5 plus e times 3 plus f equals 0. So that's going to be the first one that we put in. Okay, and then I'm going to show you how to do the rest. Just going to show you the rest. You know how to plug in the numbers. Okay, so this is going to turn into this right here. Okay, so we have everything all set up. So what we're going to do is simplify everything and just write it out. So this is going to be 3d, or no, sorry, 5d, already screwed up the first part, plus 3e plus f equals, now I know that that's over there, this is a 25 and a 9, so that makes 34, so this is going to be negative 34, okay, right there. So that's my first set. And then the second set's going to be negative 2d plus 2e plus f is going to be equal to, let me see, this is going to be 4, this is going to be 4, so that's 8, so that's a negative 8. Yep, let me check my work with what I did earlier. Okay, and then this is going to be a negative d minus 5e plus f equals, okay, so this is going to be 1, this is going to be 25, so this is going to be negative 26. Okay, now my highest recommendation is for either you to graph this in a three-dimensional plane or to use matrix solutions to actually solve it. I highly recommend that. So in the matrix, when you make it, it's going to be the constant matrix times the variable matrix equals the answer matrix, and you need to do the inverse of the constant matrix, and you need to times it by both sides. You'll see why. And if I do it to one side, obviously I need to do it to the other side. Okay, because this turns into the identity matrix, which is just those ones and zeros. Okay, oops, let me bring that to a capital C. And so this is going to be equal to okay. Alright, so I'll go to a different screen and show you how to put this in. Alright, so here is my left side of the matrix. This is my constant matrix, all the numbers with the E, D, and F. Okay, and then this is my answer matrix, the numbers on the other side. So what I'm going to do first is find the inverse of this. So I'm going to go down here and find a to the negative 1. Okay, and then what I'm going to do is I'm going to replace that with this. So this is negative 0.16, 0.02, 0.02. Okay, trust me, finding the inverse matrix of a 3 by 3 is a lot more pain than what we need to go into right now because we're just trying to solve this. 0.32. Okay, so now I've got, this is now the inverse matrix of that constant. Okay, so what I'm going to do is I'm going to multiply this on the left side with this on the right side. Okay, so I'm going to go A, matrix A times matrix B. You can probably do this on your graphing calculators a lot faster, but I'm just showing you by hand just to show you the method. Okay, and then I'm going to go these two, and I found out what D, E, and F are. Okay, okay, so I found out D to be, what was that, a negative 4, E v2 and f to equal, what was that, negative 20? Negative 20, yeah. Okay, and so when I write out my equation, it's going to be x squared plus y squared minus 4x plus 2y minus 20 equals 0. And voila, I actually have my form all set up so that I can actually show you that this is this right here. Now that's the general form. If I wanted to do the standard form, I would just do completing the squares again, and I'd probably get, let me see, x minus 2 parentheses squared plus y plus 1 squared equals, let me see, put the 20 on the other side, 24, 25, 25. And it would be a circle with the center being 2 comma negative 1, and the radius is equal to 5. Voila. That is it. That is the perfect way to actually do this. So please follow this method whenever you're trying to solve one of these bad boys when you're modeling, okay? Alright? And that's how you do it when you are working through a circle and just trying to find the equation of it, okay? Alright, thank you very much and have a great day. Bye.